Hello. Okay, you should see the desktop now. Can you hear me? Is everything seem okay?
Hello, Professor. Yep,
Yep.
Hi.
everything looks okay.
Okay, great. Thanks. Okay, let me get some windows up. Okay. Okay, people are still coming in. Okay. So we had the test on Thursday. You probably won't get the test back until next week. It takes a little while to grade these. So you won't be getting it back this week. I hope you'll get it back next week. And if I remember right, is fall break this coming Monday and Tuesday?
Yeah.
Yeah.
Yeah. So we won't have class the 12th and 13th, right?
Yeah, I think so. Monday, Tuesday.
Yeah. So hopefully then you get the exams back that following Thursday. Well, you'll get them on Brightspace, actually. Yeah, I can't hand them back to you. So you'll get your graded results on Brightspace, hopefully, sometime next week. Okay. So we're going to start, like this week, we're going to start talking about loops. So today we still I want to finish. We didn't finish talking about everything in these two sections here. So that was the last reading before the exam, but that wasn't on the exam. And there's a couple things to talk about in these two sections here. And then we're going to start talking about what's in loops. The next main idea in programming, the idea of loops. Okay. So this is something this is the last thing to finish up from the chapter on if statements. And there's a lot of overlap between this and what we're going to talk about loops, because this stuff here is really about Boolean expressions, not so much about if statements. Is about Boolean expressions, and loops also make use of Boolean expressions. So everything in here, this stuff about compound Boolean expressions and comparing objects is just as important to if statements as it is to loops. It's important to these two sections could have been in either chapter, the chapter on if statements or the chapter on loops. Okay, so they put it at the end of the chapter on if statements and kind of a bridge to the chapter on loops. Okay, so what we're talking about is combining. Well, let me show you one thing real quick. I put a little zip file up on the website that I put uh, picture tables from other textbooks. They're nice summaries. Okay, so I created this zip file, and in it is just a bunch of pictures of tables of information that can be useful. Okay, now one of the things in here are the relational operators. These are our basic building blocks for things that can be true or false. So they compare numbers. So you can ask if two numbers are equal or not equal. You can ask if one number is less than another number, greater than another number. So these are our basic things that gives us Boolean things that are true and false. Another place where we get Booleans is in the string class. You can ask a string if it equals some other string. See, that gives you a true or false answer. And you can also ask if two strings are equal if you ignore case. You know, are the letters the same, but maybe some are uppercase and some are lowercase. So you could ask if two strings are the same, ignoring case. That gives you a true or false answer. Then there's another place where in the string class where you can get a true or false answer. This other table, you can ask if a string starts with some text. That gives you true or false answer. You can ask if a string ends with. Okay, so we have a couple different things that give us answers that are true or false that we can put inside of if statements. We can put comparisons of numbers, and we can put questions about strings. And then we can combine these. So for example, the length of a string is a number, so you can compare the length of a string to some other number. You could ask, is the string less than 5 characters long? So that would be a true or false statement. Okay, now what we want to talk about is building up what the book refers to as compound Boolean expressions, meaning building things up with and or to more complicated things. Okay, like let me type something into I'm starting up Dr. Java. It's taking a little while. There it goes. Oh, it's stuck. Every once in a while it comes up stuck like that. So close it and restart it. Okay, see, it's not stuck this time. Okay. All right. Yeah. A simple Boolean expression is something like is X less than Y. Okay. Or another Boolean expression is something like hello starts with HE. Okay. Okay. X less than Y. Well, that whether that's true or false depends on what the value of X and Y are. This one is true. Hello starts with HE. I can change that to be some string dot starts with HE. Then whether it's true or false depends on what this string is here. Okay. What about if I want to combine things? What if I want to know, we're interested in things like, is X less than Y and Y is less than 0, something like that. Okay. That's asking a compound thing. You want two things to be true. You want X to be a number less than Y, and you want Y to be a negative number. Okay, so that asks a compound question. It asks two things, but we want to know the result of asking both of them. And then,
can you ask more than two questions? Asking more than two true or false questions.
Well, you can put as many ands as you want. Is this what you mean? Like I could also say and,
yeah.
and X is, say, and okay, so what is this asking? Think about it. This is saying X is less than Y, and Y is less than 0, and X is greater than negative 100. See, I'm asking three things. So I can keep doing this. I can keep asking three things. If you think of this as a number line problem, try to think of the logic of that. Here's a number line. Here's 0 on the number line. Here's, I'll do it this way. Here's negative 100 on the number line. Here's 0 on the number line. I want Y to the left. So so for this to be true, Y's got to be somewhere over here on the left of 0. And X has to be to the right of negative 100, but X has to be to the left of Y. So I would be wanting something like this, that X is there and Y is there. And I have, whoops. So I'm asking, is it true that X is to the left of Y and Y is to the left of 0, but X is to the right of negative 100? So that would be true. On the other hand, if I took X from away from here and moved him over here, then it'd be false. See, that compound expression now would be false. X is less than Y is true. Y is less than 0 is true. X is greater than negative 100 is false. So I don't have all three of these anymore. So I can put as many of these as I want in here. I can put another and over here, and I can ask a fourth thing if I wanted. Okay. Okay. So we want to build these compound things. Like for example, another one. Suppose I moved Y. Suppose I put X over here, but I moved Y over here. Now Y is over here. Okay. Now see, is X less than Y? Is that true? X is to the left.
Yes.
That one's true. Is y less than 100? Or, I'm sorry, is y less than 0?
No.
No,
No.
so I admit, yeah. Now, so I've got this one true, this one's true, but this one's false. So this whole thing is false. The and is saying I want all of them to be true. So this whole thing is false. If I were to wrap an if around that, and then say, here's what to do if it's true, here's what to do, and then here's what to do if it's false. Okay. If I wrapped an if around that, this guy is false, so I would be down here. This one's true, but this one's false, so I don't have all three of them. Okay. As an aside on this, here's what makes it true. Remember, if I put the y there, that makes it true. I've got x is to the left of y, x is to the right of negative 100, and y is to the left of 0. That's what I want. I cannot write that. Here's something that students always want to do. That Boolean expression up there, everyone wants to write it this way. I'm asking, is x to the right of negative 100, but to the left of y, which is to the left of 0? Okay. In an algebra class, you can write what I just typed. Whoops. You can say, I want x to the right of negative 100. I want x to the left of y, and I want y to the left of 0. That's a nice way to say that. Algebra classes let you write this. Java doesn't. You have to write it with the ands. Now, see, if you think of it, you would read this, negative 100 is less than x, and x is less than y, and y is less than 0. I mean, if you think about in an algebra class, you read that from left to right, but you put the ands in there. Negative 100 is less than x, and x is less than y, and y is less than 100. Java makes you say the ands. X, and if I want to, I should or to make this easier to read, I think it'd be better if I put things in the right order. I don't have to put them in that order, but they're a little bit easier to read if I write them in that order. Okay. I want negative 100 to the left of x, and x to the left of y, and y to the left of 0. I want the picture to look like this on the number line. If that's true, then I'm in here. Otherwise, I'm over here. I can't write it like this. It'd be great if Java lets you write it like this, but Java doesn't. So you cannot write it. You can't write it this mathy way like you do in an algebra class. Java simply doesn't let you. You have to explicitly say the and. Notice it. This one here is that one. Okay. But this one here is that one, but you have to put the and in between. So you have to write x 2 times. See, you have to say negative 100 is less than x, and x is less than y. The nice thing here is you can just say negative 100 is less than x. Then you, in your mind, you think and x is less than y. Then you think and y is less than 0. Okay. Java doesn't let you write that, and that's a real common mistake to make. That won't compile. Okay. It says in algebra exactly what you want to say, but it doesn't say it in Java. It doesn't say it in the Java language. It just says it in the algebra way. Okay, so you can do as many of these as you want. You can just keep saying and. Okay, you can say, yeah, I don't know if I can put another and in here. Yeah, I've got 2 numbers and I want this one less than this one, and I want this one to the right of that one, and I want this one to the left of that one. I could say I could have a third number, and z is to the right of 0.
I have a question.
Sure.
What does the single and have any use?
Yes, but we won't learn about it in this class. You'll learn about it. It's got to do with something called bits. And in the architecture class next year, first semester, second year, sophomore year, you take an architecture class, and you learn about bits and bytes. And the single and, the one that's written like that, is about bits. This is about Booleans. And you have to learn what bits are as opposed to Booleans. So the single and has a meaning in Java. This will compile, and it won't do what you think it does. It will compile, and it won't give you the right answer. It won't be what you want it to be. So you have to use 2 ampersands to mean the logical Boolean and. And the single ampersand, you won't learn really what it means until you learn about bits and bytes inside the computer. Okay? So, and same with the single bar. Like if you were doing ORs, you write 2 bars for ORs, and a single bar has a meaning, but it's in meanings in terms of bits and bytes. Okay, so we have 2 kinds of compound. Now here, let's do like an OR one. Suppose I did something like if x is less than okay. Then there would be the true case and there would be the false case. Okay. Okay, what's this at? Think about this one on the number line. Okay, I've got a number line, and here's 0 on my number line, and here's, say, 10 on my number line. So there's 0 on my number line, and there's 10 on my number line. Okay, what does this want? Tell me in words, what is this? What makes this true? Where can x and y be?
Either x needs to be on the left of 0, or y needs to be to the right of 10, or both.
Or yeah. So what if I had y right there? Okay, that makes this one false. Y is not to the right of 10. And if I put, say, x right there, I don't have this one either. So now I don't have either of these. I've got x and y both sitting inside between 0 and 10. So x is less than 0 is false. Y greater than 10 is false. So this thing is false. Now, what will make it true? I could either move x over here. Okay, now this is true because I said x is less than 0 or y is greater than 10. The or means I want one or the other of these. I want one of them to be true. And meant I wanted all of them to be true. Or really means I want at least one of them to be true. This guy's true. I've got x less than 10. So this whole thing is true. On the other hand, I could put x back here, but I could move y out to here. Now, if I move y out here, okay, I'm all right. I asked for x less than 0. Well, I didn't get that. Or I want y greater than 10. So I asked for 2 things, and I got one of them. So this thing's true now. Okay. So this was true as long as one of the numbers is not in this region here. If one of the numbers isn't in between there, I'm sorry, if one of the numbers isn't between there, then it's true. If I want one of the numbers not in this region here. Okay. All right. So that an or in general, or is a compound thing. It combines 2 Booleans. That's a Boolean because it's true or false. That's a Boolean because it's true or false. This compounds them, combines them. So now I have a compound Boolean, and or means I want both of them. Okay, I want one. I'm sorry. Or means I want at least one of them to be true, and meant I wanted more than all of them to be true. Let's see. I could put a third thing in here, or some number z is, okay, I'm going to do something even more, I'm going to do something more complicated. Now, in Word, this is the kind of thing I'm going to start asking you like on the next exam. In words, what is this asking as a whole? Okay, we want to say it in Word. This one's saying we want X. Okay, there's a bar right there. This one says we want X on the left side of that bar. This one says we want Y on the right side of that bar. What does this thing say in between here? What does all this say?
That z needs to be between 0 and 10.
So it needs to be in that bar, right? What makes this whole expression true?
Any of those three.
So I'm either asking for X to be out here, or Y to be out here, or Z to be in here. Okay? See, I've written a kind of complicated expression that says I either want X less than 0, or Y greater than 10, or Z between 0 and 10. Okay, so I've got three, I'm building a compound expression out of 3 ors. This one says I want X here. This one says I'd like Y to be here. And this one says I want Z to be in here. Okay, now what would make this false? Why is this one false?
Because none of them are true.
Because none of them are true. I didn't put X less than 0. I didn't put Y greater than 10. And I didn't put Z in between 0 and 10. So it's false because I didn't get any one of the 3 to be true. Okay. Yeah. So I can build, notice that I'm building now a complex thing out of ors, and ands. And I'm using the number line to kind of make this logic so you can see it as a picture. Now, normally, we don't draw number lines. A lot of times we do this stuff more abstractly than just something like this. But in these cases, you can actually see these Boolean expressions as facts about a number line, which makes it a little bit easier to read them. I'm asking for, what if I change it to be this?
Then it all has to be in there.
Yeah, now I'm saying it must be, for this to be true, it must be that X is better be in this region, and Y better be in out here, and Z has to be inside. This is if I make a specification like this, I'm basically saying X is in his box, Z is in his box, and Y is in his box. I have a box that the X must be in. I have a box that the Z must be in. And I have a box that the Y must be in, and this thing says that they're all 3 in the right box. If I put the ors in there, then it's saying that, well, one of them is in the right box. Okay. A little bit trickier is, what about this? In words, what's it saying now?
The first condition must be satisfied with X being less than 0, Y greater than 10, or Z has to be between 0
but what
and
you
10.
did is you just read it from left to right. So you didn't see, but you didn't really say what it's asking. Like, remember a minute ago I said that if I write it this way, I'm not going to read, okay, I can read it. It's saying that X is less than 0, and it's saying that Y has to be greater than 10, and it's saying that the Z has to have the Z greater than 0 and the Z less than 10. Okay, but what is it also saying? It's saying that X has got to be in this box, Z's got to be in this box, and Y's got to be in this box. Okay, notice that that was like a much higher level description. I've got the number line divided into 3 boxes, less than 0, between 0 and 10, and to the right of 10, greater. And I'm saying this thing's saying that X has got to be in his box, Z in his, and Y is his. Okay, that's not reading it from left to right. That's kind of saying what it's really telling me, that I've divided number line into 3 regions, 1 region for X, 1 region for Z, 1 region for Y, and I want all 3 of them to be in the region. If I change that to an OR, and I change that to an OR, well, what I'm saying now is that I've got the 3 regions, and I want one of them to be in the right region. Yeah, so here's the region for X, here's the region for Z, here's the region for Y, and this is true when one of them is in the right region. Okay, what is hard is this one here. What is it saying about the regions? You know, can we explain this one? Now we can read it from left to right. It's saying that it's true when X is less than 0 and when Y is greater than 10, or when Z is between 0 and 10. But what is that really saying about X's, Y, and Z in this thing, or this thing? This one's much harder. You know, changing that or to an and actually makes it quite a bit harder. Let's try, okay, let's, like right now, is it true or false?
It's true.
Let's see. X is less than 10. That part is true. Y is greater than 10. That part is true. So that means that this part is true, because this is saying this is this and this. So this one is true and this one is true. So this one is true. Now we have an OR. Whenever we have an OR, but we know that one of them is true, it doesn't really matter if this one's true. Remember, OR only wants one or the other. So
Wait,
this whole thing, pardon me?
excuse me, wouldn't you have to put parentheses around the X condition and Y condition?
That's a real, see, yeah, that's what I was kind of leading up to, is there's an issue here about order of operations. Okay, right now, no, I don't need to put, if I leave it like this, I don't have to put parentheses, because the order of operations is that this is done before this is. Okay, let's switch to something you're more familiar with. Go back to arithmetic. What's that equal?
23,
Why?
because you do the multiplication first, order of operations.
Yeah, because you don't just read it from left to right. And the truth is the same over here. You do not read these from left to right. There is an order of operations actually involved. So here you have to look at it and say, well, wait a minute, I have to find the first operation to do. Multiplications come before additions. So I actually jump over here and do the 4 times 5 before I can do the add 3. Okay, so I get 4 times 5 is 20, then add 3. Okay, multiplication is before addition. So multiplication before addition. Okay, here's a trickier one. How do you do something like that? Now notice, oh, let me go back up here. Suppose I did want you to do the addition first.
Add parentheses.
Add parentheses. See, now, if I don't have to put these parentheses in, why not?
Because following order of operations. is
Right.
done
So the
first.
order of operations says that those parentheses are redundant. On the other hand, if I really did want you to add 3 plus 4 first, I have to then put in the parentheses. Okay. So I add parentheses either to make it easier to read or to change the order of operations. Same thing's going to be true up here. Like this parentheses was needed. I could put parentheses around these if I wanted to make it a little bit easier for you to read it, but they don't change the order of operations. that parentheses there doesn't change anything, but this parentheses was needed. It did change something. It lumped this one with this one. Okay, so, oh, and this parentheses is part of the if statement. It's not order of operation. If statements begin with the parentheses there and end with the parentheses there, which is not part of the order of operation. Okay.
Wait, in Java's order of operations, which one trumps, and or?
We'll look. A good question. We'll look it up in a minute. I'll show you where the table is that tells you this. If I remember right, and trumps or. And acts like multiplication, or acts like addition. That's usually the way people remember it. And is like addition, and is like multiplication. Did I say it wrong? And is like multiplication. No. Yeah, and is like multiplication, or is like addition. Okay. And acts like multiplication, or acts
Wait,
like
so
addition.
so what exactly do you mean by that?
This. Multiplications come before addition.
Which one is which for and?
Oh yeah,
And,
yeah, okay.
yeah, and is like multiplication. So ands before ors.
Are there any other operations in the
Yeah.
chain?
Yeah. We'll look at we'll look at them in a minute. Okay, what's true about this one here? How do you do this one?
It just goes left to right, correct?
Yeah. When the order of operations aren't one higher than the other, you do them from left to right. Now, subtraction does not come before addition. They're done left to right. In this line, you do the subtraction for the addition. In this line, you do the addition before the subtraction because you do them from left to right. Okay. And for example, on line 40, which is done first?
Multiplication.
Because it's on the left. Because multiplication and division are the same from this point of view. Multiplication is done before, they're the same, so multiplication comes on the left, so it's done first. Here, division is done first because it comes on the left. Division and multiplication have the same order, so their combinations of divisions and multiplication are done left to right. Additions and subtractions have the same order, so combinations of additions and subtraction are done left to right. But multiplications and additions do not have the same order. Multiplication comes before addition. Okay? If I write this, this is not actually done left to right. It's done, division comes before subtraction. It just happens that I wrote this on the left. So for example, here, division's done first. Here, division's done first. Divisions come before subtractions. Okay, so here I'm not using left to right. I'm using the fact that divisions come before subtractions. See here, I'm using the fact that multiplications come before additions. And there's nothing special about subtraction. Even if I put addition there, division is before additions. Division is before additions. Okay, but if you have nothing but additions and subtractions, left to right, nothing but additions and subtraction, left to right, nothing but multiplications and divisions, left to right. Okay, now for the logical operators, let's go back to that little folder. I put one of the tables I put in that folder tells you the answer. It's this operator precedence table. Okay, the things higher in the list are done before the things lower in the list. Okay, so here and comes before or, but like let me I don't want What's the order of operations here? Let's look in the table. Okay, what would you want this thing to be? What do you think someone means when they write this?
To do the left side 3 plus 4 to see if it's equal to the right hand side of 5 times 6.
Yeah, and what they don't want you to do is compare 3 with 5, or 4 with 5. Okay, so they don't want you to do the equals equal first, but there's no parentheses. Now, if I parenthesized it, then it's real clear what you probably meant. Okay, but Java, in this case, what does Java think of this without the parentheses? Well, let's look on the table. Here's equal equal. Is something that what's done before it? Well, addition. See, so that addition is done before equal equal. Okay, so this guy would be done first before the equal equal. But on the other hand, what comes even higher on the list? Multiplication. So here's how Java, here's the order that Java does this. Java will do that first because multiplication's highest in the list. Then it gets 30. Then it looks for the operator that's next in the list. Well, plus comes next. So it does plus, gets 7. And then equal equal is lower in the list, so it does that last. Okay? Okay. So equal equal is done. Now here's an interesting one. Suppose I ask you this. What am I ORing together, do you think? Or another way, what am I asking in this question here?
Either x equals y or z doesn't equal w.
Right. I don't want to do the ORing of, I don't want to OR that. But without parentheses, how do I know I'm not ORing that? Okay. Well, let's look at how Java would do this. We want it to be exactly what you said. First, compare x with y. Find out if they're true or not. See, find out is that true or false. Then compare z with w. Find out that's true or false. We want one of them to be true. Either we want x to be equal to y, or we want z to not be equal to w. We either want x and y to be the same, or z and w to be different. Okay, let's check the order. Does it do what we want it to? Now, we can always put parentheses. If we put parentheses like this, there's no question left what we're doing. And there's an old rule in programming, always put as many parentheses as you can in your expressions to make it obvious what you're doing. But not everyone does that. And you do need to know how to read these without the parentheses. So a good Java programmer would put parentheses there and there, and there, and there. So they're not needed, they're redundant, it's wise to put them in there, okay? And a good Java programmer would put parentheses there and there. Very much redundant, but not a bad idea to put them in there. In the long run, it's wise to put in the parentheses, okay? But you still got to be able to read these without the parentheses, because you're going to read the code that somebody wrote who didn't want to ever use parentheses, okay? So you have to read their code too, okay? So let's check what goes on here. OR is down here. What happens before OR? Well, notice here that these two are the same level and they're higher, so they're done first. Okay, now which one is Java going to do first? Is it going to ask is x equal to y, or is it going to ask is z not equal to w?
If x is equal to y,
Why?
because it's on the left. And it's
Yeah, you do left to right. When things are the same level, you do them left to right. When things are on, see, like addition, subtraction, or multiplication and division. So we were saying that when you have nothing but additions and subtractions, you work from left to right. So equal and not equal are on the same level, so you do them left to right. So if I did this, now which operator is done first?
does not equal.
The not equal is done first, because why?
on the left.
It's on the left. So Java will actually do that first. Now it's important which one it does first, because if this is true and it's an OR, what does that tell you?
It skips the other part.
It skips the other part. So you kind of want to know which one it does first, because if this is true and it's an OR, you're done. You've got one of the two things you wanted. It actually skips the other part. And there's time when it matters to you what order these are done in. Like maybe you don't want this one to be skipped. So if there's one of them you don't want to be skipped, here's a famous example. It matters if I write, okay, now let me write this the other way. Compare that to this. This is good, this is bad, but they seem to say the same thing. This is good, this is bad, but they sure seem to say the same thing. What makes this one good?
It specifies that x cannot equal 0 before it would be 1 over x, but the other one does not. And if x is 0, it's undefined.
Right. So suppose x is 0. This will blow up on you. You're dividing by 0. So it'll blow up on you, and then you got a problem. See, it tried to do this first. Well, actually, did it do it first? Oh, actually, wait a minute. Does it do it first? Does it really do this one first? How do I know it does this one first before it does this one?
Because it's before in the order of operations.
Yeah, see, less than's come before not equal in the table. So yeah, this one's done first. Okay. Well, actually, oh, I'm not, but not. I have to be careful. In this case, this one is not done first. Okay. Yeah. With ands, you always do the left side first. Actually, I should have said that earlier. With ands, you don't use this table. The table's for what's inside of the left-hand side or what's inside of the right-hand side. Yeah, I'm sorry. For an and, you always do the left-hand side first and the right-hand side second. Yeah, for an and. So the order in the table is for what's in the left-hand side. Then if there's multiple things in the left-hand side, then they're done in the order of the table. So for an and, and same for an or, you actually do you always do the left-hand side first, then the right-hand side. I made a mistake earlier. I was getting carried away. For an or, you always do the left-hand side first. The order of operations are if you have multiple things in the left-hand side. For an and, you always do the left-hand side first. The order of operations only involves if you have multiple things in the left-hand side. Because you want to be, if the left-hand side's true for an and, if the left-hand side's false for an and, you don't do the right-hand side. If the left-hand side's true for an or, you don't do the right-hand side. Okay. So here, if x was really 0, you'd blow up. But here, if x is 0, this is false, you don't do the right-hand side. So you don't blow up. You just skip over the right-hand side. So this is a nice little trick. This prevents you from doing the division when x is 0. Because the left-hand side is done first, but if x is 0, because of the left-hand side of an and, if the left-hand side of an and is false, you don't do the rest, you don't do the right-hand side. Okay, so for an and, you always do the left-hand side before you do the right-hand side. For an or, you always do the left-hand side before the right-hand side. But within the left and right-hand side, you follow these order of operations. Okay? All right, now we go back over here, okay? And what's the order of operations here? Do the and first, which would be this. So that would be like putting parentheses here and here. So the order of operations would be do the and first, because and is done before ors. If this so this expression was asking, are x and y in the right place, or is y in the right, z in the right place? Okay, so notice that the subtlety of it. Let's go back. What's this asking in a high level point of view? Box for the x's, box for the z's, box for the y's. What's this asking?
Wouldn't it just be if any of them are in their box?
Yeah, is one of them in the right box? Is one of them in the right box? Okay. Notice I'm not reading it from left to right. I'm telling you what it really does. What does this one really do?
If all of them are true?
Well, what do you mean? True. Are all of them?
If x is less than 0 or
No, don't
y
read
is-
it from left to right. Tell your boss in the language he wants to hear, what is this really saying?
Are they all in their box?
Are they all in their box? Are they all in the right box? Notice, think abstractly, think in a higher level. Your boss doesn't want to hear you say, well, we checked if x is less than 0 and y is greater than 10, and we checked for a parenthesized expression that 0 is less than z and z is less than 10. He's going to go, no, cut the gobbledygook and tell me what this means. You know, that's what people want to know. What does it mean? Well, what it means is I got a box for the x, a box for the z, and a box for the y. And now I'm checking if all three are in their box. Is x in his box, and is y in his box, and is z in his box? Before I was checking that one of them was in their box. Okay, notice big difference between reading it from left to right and telling me what it means. Okay, now a little bit trickier one. What's that one saying?
Are both x and y in their box, or is z in its box?
Yeah, I'm happy if both x and y are in their boxes, or if z is in its box. See, I want x and y in their boxes, because this is really the parentheses. The order of operation here is like this. So this is saying x is in his box and y is in his box, or z is in his box. Okay, so this is a tricky way of saying what we want is either z in the right box or x and y each in their box. Okay, now play a little bit more game. Change this one to an or and this one to an and. See if we can figure out what this one might mean. Okay, okay, I don't know what this one means, but let's try and figure it out. What is the order of operations now? What is done first?
Would it do the big and first, the whole left side and the
Okay.
between the and?
There's an okay. Here's an and. Let's call him A, and here's an and. Let's call him B. Which and did you mean?
A.
Okay, A. So A, this and is done first. Okay, but what's he anding? What's on his left?
That or statement.
No, unfortunately, no. See, that would be putting the or above the and. See, then you'd have to do the or before you had to do the and. See, to say the or, so what's on his left is just that. That's what's on his left. See, he's only got one thing on his, see, if I grouped it like this to put all of the or on his left, then I'm saying the or is done first. So that would mean that the or was done higher, see now if I lump it like this, now what's on the left of of him, what's on his left is the whole or, but I had to put parentheses around them. Okay. If there's no parentheses around them, what's on his left is just this. Okay. That's what's on his left. Okay. So he's done first. This is on his left, and all this is on his right. So what's being asked first?
If y is greater than 10,
No, don't
Or
read off. Talk
if
at a
y
higher
is in
level.
its box, or if z is in its
Yeah.
box.
Yeah. So right now we're checking first if do we have y in the right box and z in the right box? Are y and z in the right box? Okay. If this is true, if this is false, we quit. If this is true, what do we check next?
Or if x is in the right.
Yeah. So if
Isn't
this is
he kind of
false,
pointless?
pardon me?
Isn't that x kind of pointless then? If
No.
that
No. Think about what is this whole thing asking high level?
Well, I thought we had to quit. I thought it did nothing if
No.
that first part wasn't true. If
Which part? Which part?
if y and z aren't in their boxes, I thought you said we like that's it. Then it's not true. But if it's part of an or statement, then it would just be if those two are in their proper boxes together, or if x is in its box.
Well, okay. Suppose this is false. This is an or. If half of an or is false, what do?
Check the other half.
Check the other half. So this or is not done left to right. This or is going to be done from right to left because this part had higher precedence. Okay. All right. So wait a minute. Did I read this right? Maybe you're right. Did I read this right? Oh yeah, I read it right. Yeah, because yeah, and's an or, and yeah, and is done first. Yeah, because of notice that this stuff's not trivial. This stuff's not trivial. But okay, so and comes before or. So this one and this one don't have any grouping. They're from left to right. So you do this one first. Okay. This one has something on its left, and since there's no parentheses, what's on its left is just that. And he has something on his right. Since there's parentheses, what's on his right is all of that. Okay, so this part here is done first. If it's true, since this is an or, and this part is true, I'm done. But since this one's an or, if this guy's false, this whole thing is false, then I have to check this part here. Now, with this and, if this part here is false, then I'm done with the and. If this part here is true, then I have to check this part of the and. So for this and, if this part here is false, I'm done with the and. If this one is true, then I do this part of the and. Then when I look at the whole answer to the and, if that thing is true, I'm done with this or. But if this is false, I do the left half of the or. Okay, so what does this whole thing ask about X, Y, and Z in their little boxes?
If y and z are both in their box, or if x is in its box.
Yeah. So this is saying that Y and Z have to be in the correct box together, or X can be in its box. So either X is in the right box, or these guys together are in each of their correct box. Okay. Non-trivial stuff, non-trivial things. To make this one easier to read, if I was a good Java programmer, I would put the parentheses there and there to help somebody say, well, you're reading this as the or of X is in his box or this combination, where this combination is that Y is in his box. And if you want, you could even maybe put another pair of parentheses there. Okay. So I've got, now notice that, oh, and then if I really want to be careful, I could put a pair of parentheses there. If I read this real carefully, this is outside all the parentheses. So I'm taking the OR of this with all that. I'm taking the OR of X is in his box, or, well, what's all this? It's an AND. It's an AND of Y is in his box and Z is in his box. So this one's saying I want either X in the right box or I want Y and Z in the right box together, each in their box together. Okay. All right. So these are real good practices in reading order of operations. Now, right now, all those parentheses are actually redundant. So I don't need that. I don't need that. I don't need either of those. I don't need that one. And I don't need that one, but I do need this pair. Because if I got rid of that pair of parentheses, that would change the order of operations. Now it would do this AND first, with this on its left and this on its right. Take that answer and make it the left of this. Make it the left of this. See, it would do these two ANDs from left to right because they are in the same level. So it would do this AND first with this on its left and this on its right. Then take that answer and put it on the left of this AND and trick this on the right, which would, I don't even know what that's going to give me. I mean, it's not what I wanted, and I'm not even sure. You know, we could pull it apart and work hard to figure out what it's saying, but it's probably not saying anything really intelligent. Okay, it probably really isn't saying something we could describe in a higher level. But if I put the parentheses back where they belong, then I'm lumping these two together in this and this is saying Z's in this box between 0 and 10. I'm now saying Z's in that box. Okay, so that has a meaning. Z is in that box. And I want that to be ANDed with Y's in his box. Okay. All right, so order of operations, read these things. You don't remember, you don't read these things from left to right. You read these things real carefully by saying, where is the first operator? Like, you know, you look at this guy and you have to say, well, he's not inside any parentheses and he's not inside of any parentheses. So, but since they're not inside parentheses, I have to go to ask which one comes first in this table. So he's done first because both of them don't have parentheses. There's no grouping here, and ands come first. So he's the one done first. Okay, so then you figure out, well, that's his left, that's his right. That leaves this guy to be done afterwards. But you have to figure that out, you know, slowly, reading real carefully. That's why I say programmers put parentheses to help their other people read their code. This would not be considered a good way to write the code because it's leaving it up to the reader to figure out everything on their own. Whereas if I put back all those extra parentheses, I'm giving the reader lots of clues about what I thought was going on. You know, so now I'm putting in all kinds of clues to help the reader. There's all the clues I would give them. Okay, now I've given them clues. This OR is not inside any parentheses. It's got this on his left. It's got all this on his right inside a paragraph. And see, notice that the program helps you see how there's a little bit of shading when you click on a parentheses. See that shading in there? If I click on this parentheses, see how it's shaded all the way across there? So, you know, the editor is trying to help you see what each pair of parentheses groups. So that groups the if statement. That groups the right-hand side of the OR. That groups the left-hand side of the OR. You know, this one groups just the left-hand side of that AND. This one groups the right-hand side of that AND. So you can see the shading goes up to there. No, wait a minute. No, I'm sorry. No, this is the right-hand side of that OR. See, the shading goes all the way up to here. Then this one was the right-hand side of that and here. See, this one here went up to there. So that parentheses closed the right-hand side of that and. Okay. The shading of the editor tries to help you see what each parentheses is blocking out. Okay.
So then the if condition would be either X or Y and Z in their boxes.
This one was X is in his box or Y and Z are both in their box.
Yeah. Okay. Got it.
Yeah. So notice how many different conditions we can get out of this. You know, we can do a lot of different, you know, we did a lot of different ones out of this. I can put them all out there. The first one was X is in his box or Y is in his box or Z is in his box. That was one of them. Then another one we did was X in his box and Y is in his box and Z is in his box. Okay, that was not. Then another one we did. See, what was the other one we did? Was it this one? Change the or? No, that's one we just did. I don't know. Let's see. What was the other one we did? Was it this one? What would this one do? I don't remember. We didn't do it. What is this one asking now? I think it's what? And is done first. Because it's on the same level as or, but and when or and are in the same level, and is done first. You want this and this or this. So what's this one asking all together?
Are X and Y in their boxes or is Z in its box?
So are X and Y in their boxes together or is Z in his box? Are X and Y in the box or is Z? So if I was to help a person read this, I would put a little pair of parentheses there to make that one easier to read. It's an or of X and Y both in their boxes or Z in his box. Okay, but I didn't need the or there. Okay, so notice how we got a bunch of different, we got a bunch of different combinations out of this. You know, we've got on the number, these make nice little problems. You know, on the number line, I've got three regions. There's one box between 0 and 10. There's another box to the right of 10. There's another box to the left of 0. And I've decided that this box is for X, this box is for Z, and this box is for Y. Then I want to write conditions that say things like X is in his box and Z and Y are in their box. Okay. I could even do more complicated things. Let's do another one. What did I do? When is this true?
If either X, Y, or Z are in their boxes.
No. I added that guy.
Oh, I missed that. Okay.
Yeah. Notice how subtle that is. Programmers do this all the time. You got to look for those little X. They're hard. They are notoriously easy to not see in code. Sometimes people put a space out there to kind of like make them stand out a little bit. Okay. That's saying not this stuff here.
So it's X is in this box, or Y is in this box, or Z is out of his box.
Yeah, exactly. So this is true when X is in the right place, or Y is in the right place, or Z is not in there. So where can Z be if he's not in there?
Less than 0 or greater than 10.
Yeah, he's either in the same box with X. So there's another way of saying it, that X is in his box, Y is in his box, and Z is with one of them. Z is either in the box with X or it's in the box with Y. Okay, that's what that little not there does. You know, so you can keep playing with all kinds of games with these. You can create all kinds of conditions about X and Y's being in their boxes and not being in their boxes. Like if I wanted to be, I can write something real fast that I can't read. Okay, I don't know what that means, but I could figure it out after a little effort. Something about X is in his box, Y's not in his box, Z is in his box, and then some kind of combination of or and with that. Okay, so you start thinking a little bit like it's saying something about X, Y, and Z in their boxes, but it takes a little bit of effort to figure out exactly what that is. You have to figure out, again, the order of operations and figure out which one's which. Okay, all right, now let's switch to something else. Let's switch to a different, so like, let me save this. Okay. The other thing we need to do, what we've been talking about is we've been beating to death compound Boolean expressions, which are, wait till you see how much we use these. Wait till you see some of the things we write in real code. This is not overly weird or overly picky or pedantic. We're going to write stuff like this pretty often. Okay. The other thing we wanted to do in this today was this other section of comparing objects. Okay, so let me go back over here. Well, actually, I'll create a new window. You know what? Here's how I ask if X is equal to Y if they're numbers. So if I have int X, int Y, I can ask, is Y equal to X? Okay. Here's where things get tricky. Suppose I have a string S1 and a string S2. Somebody gives them values, and I want to know, is string 1 equal to string 2? And that's not the right way to do it. That's not a good way to ask if strings are equal or not. In fact, it usually will give you it will compile and it'll give you an answer, but it's usually not what you thought you were getting. If you want to know if two strings are equal, you have to use what's called the equal method. You call this method on this string, and you're asking this string to check if he is equal to this other string. So you're actually asking this string to do some work for you. You're asking this string to check if all his letters are equal to all his letters. And the answer is going to be true or false. This is not the right way to do it. This is the right way to do it. Okay. Now to see why.
What do you need to import to get the equals method?
Nothing. It's there automatically. It's part of the string class. It's part. Oh, see, go over here. Some useful methods in the string class. See, remember, it's right there. See, it's part of string. See, along with all the other methods, char, at, length, to lower, to upper, it's just one of the methods in the string class. Okay. Same with turtles. If you want to know if two turtles were the same, if you had a turtle T1 and a turtle T2. And for some reason, if you want to know that if they were equal to each other, were they headed in the same direction? Yeah, were they the same turtle? That's not the right way to do it. If you want to know if two turtles are equal, you're supposed to do T1 dot equals T2. And equals is be part of the turtle. Every turtle knows how to compare himself to some other turtle. Okay, now let's go to the Java visualizer and play a little bit and see why this is let's see in a visual way what's the difference between this and this. Okay, I'm going to start with their code here so I don't have to type everything and go over to the Java visualizer. Now I want to add a little bit of code to here. I'm going to make some changes in their code.
Wait, question.
Mm-hmm.
On line 10, does that mean that you would print them only if they were equal?
No, no, no. This is either going to be true or false. You're going to either print the word true or you're going to print the word false. See, it's not an if statement. An if statement is the only thing that branches to do one thing or the other thing. This isn't an if statement. This is just something that is either true or false. So you print the word true or you print the word false. Okay. To do one thing or do another thing always has to have an if statement. Okay. So if you said if this is, then you saying do one thing or the other. But print always prints. So print will always print something. It'll print whatever this is. And that's either going to be the word true or the word false. I'm creating a lot of hellos. And the question is, like, why in the world would I be doing this? Why do I want so many hellos? Okay. Now, in the visualizer, if you want to play with strings, you got to go here and say show strings the right way. Otherwise, this will not make sense at all. So you got to go here and make sure you say show strings the right way. Now watch what happened. Oh, what did I do wrong? What did I do wrong? Oh, I did two S3s. So this has got to be an S5. Yeah. S1, S2, S3, S4, S5. Okay, so there's an S5. Okay. Notice that line 5 created a string object. Line 6 created another string object. Line 7 created a third string object. Now here's the tricky part. Line 8 is not going to create a fourth string. When you use this notation, every time you use it, it's the same string. When you say new string, you keep getting different strings. So this and this are two different strings. This one's a third string, but this one is still that one. Okay, so that's weird. Okay, that's just a strange quirk of the Java language. When you use new on a string, you actually get a distinct string. Otherwise, you just keep getting the same string over and over again.
Is it any different in practice?
Pardon me?
Is there any difference between the two in practice?
No. Oh, well, just as the fact that you get these different arrows. The strings themselves are exactly the same. You get these different arrows, but they are actually the same kind of string. So this string is absolutely no different than this string, but the way the arrows are created is different. So it's quirky. It's really weird. Okay. Now, when you do something like this, Okay, let me do S1 compare with S2. S1 compare with S3. No, we're out of time. I just want to do, what do these things mean? I'm not printing the answer, so I won't see the, so, okay. What's S1 equal S2? What's S1 equal S3? What is S3 equal S4? What did I do wrong? Oh, B1, B2, B3. Is S1 equal to S2? S1 is hello, S2 is hello. Seems okay to me, but it's false. Because here's what I did. S1 is that arrow. S2 is that arrow. Those two arrows don't point to the same thing. That's why it's false. This asks, what's the arrow? This asks, is S1 arrow equal to the S3 arrow? The answer is going to be false. This asks, is the S3 arrow the same as the S4 arrow? The answer is yeah, they point to the same thing. See, that was true. This asks a question about arrows, which is usually not what you want. You usually don't want to know, does the arrow in S1 point to the same thing as the arrow in S2? Does the arrow in S1 point to the same thing as the arrow in S3? Not to the same the value, to the same actual object. Okay. Now compare that to, just give me one more. Just do Boolean before S1 dot equals S2. Now this asks for not about arrow, it asks about the data in the object. Okay. 9 asks about an arrow. 10 asks about an arrow. 11 asks about an arrow. This says, look in S1, HELLO, and compare the data in S1 to the data in S2. Compare HELLO to HELLO, and the answer is going to now be, no, see, this was false, but this will be true. Okay. The way we put it is, this compares data, this compares arrows. Okay. If we go back over to my little notes over here, compare arrows, compare data. Same down here, compare arrows, which is a hugely different issue. Compare the arrow in the reference variable versus comparing the data in the object. Compare arrows in reference variable versus compare data in the objects. Compare arrows in the reference variables versus compare data in the objects. Hugely different. So we have run out of time. We have to end there. But boy, is this a big issue. You know, we're going to keep coming back to this over and over again. The difference between asking, are the arrows equal, the arrows in the reference variable, versus asking, are the data equal? The data in this object equal to the data in this object. Okay, right? So we're going to keep, that's what this section on comparing, oops. See, that's this whole section comparing objects. the difference between equal, which compares the arrows, to dot equals, which compares the data in the objects. So, okay, we've gone over 5 minutes over. Anybody got any last minute question? Anybody got a question? Okay, I'll put these examples up on the course website. And what we did today is tricky stuff. Everything we did today is tricky. The difference between I've got students in my senior level programming class who are still mixing up this with this, who are sending me their code saying, why doesn't my code work? And I see them using this when they should have been using this, and their programs are bombing out because they're using the wrong equals. It's such a tricky thing. People forget about it, and they keep making that mistake of using this instead of this. Yeah, and then also this stuff we did with the all these compound Boolean expressions can be hard to read. It can take real effort to parse your way through this and say exactly what it's doing. So everything we did today is tricky stuff. Okay, any last question? Okay, so we'll probably start talking about for loops. We need compound Boolean expressions and we do for loops. So we're not going to go away. We're not going to drop this topic. We're just going to change if to while, and we're going to be talking about the same thing. We're still going to be talking about these compound Boolean expressions. We'll just change the word if to the word while. There won't be this else down here, but then we still use the same stuff. Okay? Okay, so I'm going to turn off the sharing. Okay, and then on Thursday, we'll start talking about while loops. So see you on Thursday. Bye-bye.